Hello and welcome again to Microchip's Memory Technology series. So what's an EERAM? Well, EERAM is a serial SRAM that includes non-volatile transistors in every cell inside the device. That structure allows EERAM to hold content through any power down event. So why is there an EERAM? That's a fair question. Many industrial applications need just a small data logging journal. These data logs usually hold running calibration information, or they capture the progress details on whatever the machine is processing at that time. Serial EEPROM is the usual solution for this. It is by far the cheapest way to go, and so is selected by designers if their applications are rewritten less than 1 million times in the product's total lifespan. Remember that EEPROM datasheets only promise 1 million store cycles for every page or byte of memory. EERAM fixes this by putting an SRAM in place of the PROM. It's built around a standard 6-transistor SRAM cell. SRAM is volatile, so to make it non-volatile, which means it will not lose its content on loss of power, a pair of floating gate transistors, just like those used in flash memory or EEPROMs today, are placed right inside each memory cell, here and here. By using 2 floating gate transistors, these floating gates can store the true and complement value and match naturally the true and complement values of each side of the SRAM bit. 2 more gates are added here to help write or reset the floating gate transistors, and then these 2 gates are added to transfer the logic level from the SRAM when power goes away, and then back onto the SRAM when the power comes back on. So EERAM has a memory cell with 12 transistors. That's quite a few, making it more than twice the size of an SRAM. But by putting the floating gates right inside each memory cell, on any power disruption, the SRAM content can be quickly transferred to these non-volatile transistors. Then when power returns to the IC, the information can be transferred back to the SRAM and to you, the user. This serial SRAM that, like all SRAMs, should lose data when power goes away, doesn't. It appears to be non-volatile. Now this is done inside the IC. All those decisions are monitored and made inside the device. The other EERAM magic is this little capacitor attached outside the IC to this pin called VCAP. It's just a regular small-sized capacitor, and when power is turned on to the IC, this VCAP capacitor is charged up through the device to VCC. Then when power is detected going away by the device, the main VCC is shut off inside the device, and the energy on the VCAP capacitor powers the device until the SRAM content is safely stored in the non-volatile transistors. Of course, the serial SRAM loses its content when the power is gone, but when power comes back, the values stored in the non-volatile transistors transfer back to the SRAM, and the VCAP is again charged up, so it will be ready for the next power down event. Here are the EERAM advantages. First, EERAM is built out of SRAM and floating gates, standard structures in most CMOS products today. So EERAM adds no strange process or chemical to the fab. It could be run in many fabs around the world, and so quality and very low field failure based on the millions and millions of CMOS products being built every month is EERAM's strongest value. The other common serial NVRAM solution is serial FRAM. It's a neat technology, but is built in an odd process at thousands of times lower volume in just a couple fabs in the whole world. So it doesn't have this value. Second, for the user, an EERAM behaves just like a serial SRAM. Same I2C or SPI serial timing interface. Same packages, so it's easy to use. Also, reading and writing bytes is symmetrical, meaning you can write a byte just as fast as you can read a byte. Also, reading and writing bytes is infinite, just like an SRAM because it is an SRAM inside. However, since NV gates are involved, the part can only see 100,000 power off, power on cycles before those non-volatile gates could wear out. Okay, now the disadvantages. First is cell size, 12 transistors per cell. So commercially, that means EERAM is offered at only small densities and only in a serial format. This chart shows the density range of serial EERAM versus that of serial EEPROM. The price delta for EERAM over serial EEPROM is about 2x across this 4K bit to 1 megabit range. So if you pay, let's say, $2 for an EEPROM at 10 KU volume, then think $4 for the same size EERAM. Second disadvantage is the VCAP. Though a novel idea and tiny and reliable, it still consumes one of the 8 available pins. See our other videos to learn more details about various memory technologies, terms, and other memory concepts.